All right, so level 1 and level 2 link state protocol data unit, LP, LSPs, and hellos, IAHs, is in intermediate system to intermediate system hellos. Two level nature of ISIs, so you need to have separate LSPs because it is two levels of ISIs. Level 1 separate and level 2 separate. From the beginning I was telling this. Now this is nothing but designated, instead of router you say IS. This is the representative of LAN. In one LAN, in one broadcast network, you will have one DIS. Same like in OSPF, you have one DR. Okay, so DIS sends pseudo level 1 and pseudo level 2. It's nothing but DIS sends, you can say, LSA type 2 in OSPF comes only from designated router. Likewise here, this is the designated router sends pseudo level 1 for L1 adjacency, pseudo level 2. So separate this for L1 and L2. Link state packet data units are sent as unicast on the point-to-point, whereas as a multicast in a broadcast environment. LSPs are sent as multicast in broadcast environment, whereas in point-to-point it is unicast. It's a layer 2 multicast address. I'll show you when we are in the lab. I'll capture some traffic and I'll show you the address. Now, LAN uses separate L1, L2 hellos, and this is also sent as a multicast traffic. Point-to-point uses a common, there is no need for separate L1 and L2. In point-to-point, you have common IAH for both L1 and L2, and there is sent a unicast, which we saw just now. Broadcast, LAN needs to be full mesh, point-to-point, you may be running PPP or HDLC. Hello timers are 3.3 seconds for this. For others, hellos are sent every 10 seconds. We know this one. But this is new information. This will send the hello every 3 seconds, 3.3 seconds. Whereas in point-to-point, we don't have this, so it is only 10 seconds. Adjacency in broadcast, everyone should be forming neighbor with all other. If you have 10, then you will have 9 adjacency, 9 neighbors. Here it is 1-to-1. And then usage of this is needed in LAN to avoid duplication of update, duplication of LSPs. Here not needed. Here we saw 2 different type of hellos. Here it is only one type hello. LSP flooding, single procedure for flooding, aging, and update of LSP. Level 1 LSPs are flooded within an area. Level 2 LSPs are flooded throughout L2 backbone. So if you have L2, L2, L1, L2, no use, there will be a break here because the flooding stops right here.
You know what's my experience that I was doing when I realized I can see what when I get it.
So L2 LSPs are flooded throughout the L2 backbone. So you need a backbone L2 in order to flood L2 LSPs, otherwise it will break. Large PDUs are divided into fragments that are independently flooded. So if it is a big size, normally fragment happens. Each PDU is assigned LSA. Okay, in case if it is fragment, they got a fragment number, so that on the receiving side they can rearrange. Separate link state database are maintained for level 1 and level 2. This we know already. Synchronization. LSDB synchronization. Synchronization SNP packets are used to ensure synchronization and reliability. Contents or label switch PDU description. So there are two type of updates that are sent in between two neighbors in order to get synchronized. One is called as PSNP, partial. P stands for here, C stands for complete. All right, partial and complete. I was giving you an example. PSNP is like LSU. This is like a DPD. Yeah. So here we saw earlier these terms, PSNP, maybe in the next chapter we saw, the configuration chapter we saw. Do you remember what does that mean? PSNP. Complete sequence, I think. Complete sequence, partial sequence, complete sequence. What is the NP? Partial sequence number PDU, not sync. It's sequence, partial sequence number PDU, complete sequence number PDU. So what is partial sequence number PDU means? For acknowledgement of LSP on point-to-point link to request missing Ps. That is why I compared this to LSU, links to the update. The missing piece of LSTB. Now, CSNP is used for the following periodically by DIS. DIS sends this CSNP to ensure everyone is fully synchronized. No, that is hello packets. Yeah. Yeah. Here, in point to point, it is only when the link comes up when they form first time adjacency. Whereas in broadcast environment, this sends it to ensure everyone is in sync periodically. Now this is the picture that explains us the difference between CSNP updates and PSNP update. Here you see R1 sends a partial sequence packet and it goes to everyone, and this is there receiving the update. And what this does is it includes that new update 77, which was not there earlier, and this will send this information every 10 seconds to others. So now this is receiving a new LSP from someone, from somewhere, someone, but it didn't reach this guy. It says, hey, I received 76, 77, sorry, 78, but 77 is missing. It is requesting for that. And here it sends the PSNP message. Is it PSNP? No, sorry. Even though it's a dotted black line, even though it is a CSNP, it's a dotted line, black dotted line. So it is sending to. Oh, no. I confused. First thing is number one comes in the CSNP. It goes to everyone, and then this guy has got some issue. He did not get clear information about 77, so he sends the PSNP. For the PSNP, this sends this info 77 as a point-to-point link state PDU to this guy, and he sends the acknowledgement. Mm. Mm-hmm. 224001 is node multicasting. It will not go to every router. It will only stay in the port. Node based. It's for the host. That multicast address is not for the routers. 224002 is what the router multicasting.